In this video, we will learn how master the API 579.1 FFS assessment procedure in 10 minutes.
So part 2, FFS assessment procedures. What exactly the type of procedure which we are going to follow, the template for each and every assessment, the roadmap for performing API 579, that is decided by this part 2. So it's common for all the parts. It's not specific to any kind of failure. So it's talks about the general law of failure and assessment, how we can carry out. Okay. So fitness for service and continued operation. Okay. So whenever we do fitness for service, basically we are going to check the suitability of the current condition of that equipment, right? So not only the current, but till the next shutdown, can the equipment run, or it has to be repaired or replaced? Okay. So suitability for current condition, running till next planned shutdown. Okay. So that is what we are going to assess. Okay, that is what we are going to decide. Okay. Now, if the component is suitable, what will be your action? If you done the API 579 and you found that suitable, you did the FFS assessment and you found that equipment is suitable for running for current operating condition, then what will be our action point? So if it's suitable, you'll find the remaining life. Definitely, if found suitable, means it's good for till next shutdown. Okay. So you don't have to be worried about repairing or replacing. Okay. Nothing has to be done. You calculate the remaining life so that you are aware what is the timeline till which I can operate this. Okay. And then continue monitoring. Good for operation. You don't have to do anything, any change in the running parameters, nothing. Okay. What if it's not found suitable? You did FFS assessment and the equipment is not suitable. It has not passed FFS assessment. Then what you'll be doing? Either we'll have to re-rate. That means lowering the operating parameters. Either I'll lower the pressure or temperature, whatever is problematic, or I'll repair that equipment. Okay. Maybe locally that thickness has reduced. So I'll cut down that portion and provide a patch plate. That kind of repair I can do. Okay. So there can be only two things. Either it's suitable or not suitable whenever we are performing FFS. So if suitable, continue with the operation. If not suitable, either re-rate or repair. Okay. Now, so before you start that assessment procedure, identifying the flaw type is a very, very important parameter. You have to identify which kind of flaw it is. Okay. So once you have decided flaw type, there are multiple points which we can talk about. We'll see that in the later. When we talk about the different parts, when we are going for the assessment of actual flaw, we'll talk about the identification part also, that how we can identify the flaw type. So depending upon the flaw type, I may select a single methodology for assessment, or I may decide multiple assessment. Okay. It may fall into any of the category. Can you give me an example where I need multiple assessment? Flaw type is one type, but I need to do multiple assessment. So we take an example of the corrosion, like metal loss. You may have general metal loss, local metal loss, or pitting. Okay. So lots of different assessments has to be performed, okay, maybe for single type. Okay. So it may be one or multiple. Now, let us talk about in detail what are the assessment procedure basically. When we say we are going to perform assessment, what exactly we are going to do? So we'll see the different steps. Now, all of these steps will be applicable for any particular type of assessment methodology. Okay, it's common. So whatever we are going to see now will be repeated in each and every part. Same steps. Okay, so steps are very important. First step will be to identifying the flaw. Okay. There are multiple rules available, but may not be always very correct, accurately or correctly can be defined into one type. So your identification of flaw may be also multiple. Okay, that you identify multiple flaw types, and then you'll be performing assessment related to that. Okay. Annexure 2B gives the detailed requirement of flaw identification. We'll cover them specifically when we talk about a particular type of assessment procedure. Okay, so we'll not cover now, but when we talk about the different assessment, we'll cover now also a little bit, but in detail we'll talk about when we cover the actual flaw type. Okay. So flaw identification, that is your first step. What will be my next step? Second step will be applicability and limitation. Okay. Second step will be the applicability and limitation of assessment procedure. Okay, I'll elaborate a little bit. Okay. When I say applicability, so first thing will be the item for which you have identified the flaw, whether it has been designed as per code or not. What will be the difference because of that? Whether the equipment which you are going to analyze, it was designed as per code or standard or not. Does it make any difference on the assessments? Calculation will be based on code. Okay, if I make one statement that the equipment was not designed as per code, can I perform fitness for service? The answer is yes, we can do. Okay, but then I cannot. Okay, now the next question, can I do by level 1 assessment? Can I qualify that item by level 1 assessment? The answer is no. Can I do by level 2? Again, no. I have to apply level 3 assessment, which is finite element analysis. Okay. So if the item which you have taken, it's not designed as per any code or standard, recognized code and standard, which is there in API 579. In that case, you have to go for level 3 assessment. Okay. So in the start itself, you'll be able to identify which assessment will be required. Okay. Now there can be other multiple types of limitation. Okay. For each and every type of assessment. Okay. So that also will, once you have decided the type of flaw, you'll go to the particular type of assessment methodology and see the applicability and the limitation provided for that part. Each and every part is having some limitation and applicability clause. Okay. So that will be our next step. Step 3, once we have decided, we need the data. All the data of the equipment. Okay. We are going to further elaborate each and every step. So you are just seeing the steps here. We'll further elaborate. Okay. So what exactly do we mean by data requirements? We'll cover that in detail. Step 4, assessment technique and acceptance criteria. Okay. So again, it will be decided by the applicable assessment methodology, what assessment techniques we are going to follow, and the assessment criteria. Remaining life evaluation. Okay. Once you have done the assessment, see the step-by-step assessment technique is given in API 579. So once a part is applicable, let us say it's part 3, which is applicable. Very clearly, step-by-step assessment technique is given. Okay. So we can follow that, do the assessment, check with the acceptable limit, again given in the code. And then once it is approved or acceptable, then we can go and find out the remaining life evaluation. If it's not acceptable, then you don't have to go to next step. Okay. Next step does not become applicable. If the item is qualified, then only you can find the remaining life evaluation. Then step 6, remediation. Okay. If you have found any flaw, if you can do something to control it, okay, then you can take that action. Okay. So that will be next step. In service monitoring, if you have found any flaws, okay, let us say it's a local metal loss which you have found. Now you keep on doing the in service monitoring. Okay, so that whatever you've estimated till next shutdown, that this will be the corrosion rate, whether it is following that path or not. Okay. So in-service monitoring after that will be required. Last, documentation. Once you are doing any assessment, you have to prepare the documents which will be part of that assessment work which you are doing. So that will be the step 8.
Want to stand out in the field of mechanical engineering? It starts with Scootoid eLearning. Our expertly crafted courses are Master Static Equipment Design with PVElite. This course includes ASME Section 8 Division 1, TEMA Standards, Column Design and PVElite. Master Welded Storage Tank Design as per API 650. ASME Section 8 Division 2, along with FEA Report Reviewer. Fitness for service with respect to API 579-1. Piping Design Code, Stress Analysis and Caeser 2. To explore more courses, do visit on our learning platform at scootoideLearning.com or click on the Learn More form in the description below.